All right, let's go through some helpful hints and tips for this assignment. First off, we've got this set of problems here. Ball is being tossed from upper story window of a building, given an initial velocity at an angle below the horizontal. So remember that this is an angle below the horizontal. That's an important thing to note here. It tells you the time that it hits the ground and its initial velocity, but that's at an angle. So you'll have to resolve this into components using sine and cosine. Make sure that you keep your x's and your y's separated so that you don't plug things into the equations that are from just the x or just the y. You don't mix them up as you're plugging them into different kinematic equations. So using this is horizontally, so this is going to be using your x. Figuring out height, this is going to be using your y. And figure out how long does it take for it to get back down to a certain height below from where it started. That's going to mostly use your y components that you're going to have to use there. So those are just some ideas as we look at that one. The next one, we've got a ball that's being kicked up onto a roof. It's going over an edge of a wall there, and there's a number of things here. So it wants you to find the speed at which it's launched, and this speed is not a velocity, so it doesn't need a direction. This is the total vector speed, so the diagonal speed. Looking at the situation, there's some information that's been given to you, such as the amount of time that it takes to get over here to the point above the wall. You can use that time with the horizontal stuff to find the horizontal component of it, and use some of your angle stuff to figure out what the total velocity is. Just a few hints there along the way. Find the vertical distance by which the ball clears the wall. You just kind of have to look at this and figure that out, basically based on wherever it's going to land at the end, how far away from where it started. If you need more help on that, let me know, and I can walk through this question in a little more detail. And then remember for this piece as well, the vertical distance by which the ball clears the wall, that's asking for this distance right here. What is that distance between those 2 points? So you have to subtract out this height, figure out where it is, then all of that. All right, moving on to the next one. Got a rock thrown upward from the ground such that its maximum height is equal to its horizontal range. So for something like this, you might want to draw a picture. Got a situation like this, ball's thrown up in the air, and even though in this drawing this is not the same thing, that this distance here is the same as this distance there. And then we're going to go ahead and figure out what is the angle theta for the initial velocity. So you can go through, basically you just have to say that the x distance is going to be equal to whatever the maximum height was. So look at your equation for the maximum height, look at an equation for the total distance when something's thrown on solid flat ground, and you can come across a relationship between these. These are looking for some sort of numerical relationship between the two, as well as the actual numerical angle. And our last question, this is a relative velocity question, police car traveling along this way, and I'd say take a look back at your relative velocity notes. So in general, we assume that for most problems, if it doesn't say a relative velocity, it's talking about velocity relative to the Earth. And so these two velocities that are given are their speeds on Earth, not considering their relative to velocities to one another. And I think it makes sense, if somebody's going this way at 3 meters per second and something's coming towards them at 5 meters per second, then they would see this object coming towards them. It gets 8 meters closer to them every second, even though they're both neither of them traveling that fast. So you have to look at that. And this, of course, is using kilometers per hour, so you can just leave them in kilometers per hour, do the whole question that way. Until you get to the end, you'll kind of need to convert to figure out this interval in seconds. So keep in mind this is a seconds is for this answer, not hours, and it's not kilometers. So you could convert this to kilometers, figure out how many hours, and then convert that to seconds, or however you feel like doing this. That's about it. So good luck with these. If you have any questions, let me know, and see you in class.